You ever just look at a date on the calendar and wonder what stories it might be hiding? Most days just kind of passes by. But some, if you look really, really closely, you'll find they connect these brilliant minds and groundbreaking ideas all across time. Today, we're going to zoom in on one of those days, February 23rd.
Like a sudden flash of lightning, the riddle was solved. Now, that's a quote from one of the greatest mathematicians who ever lived, Carl Friedrich Gauss. He's describing that incredible aha moment of discovery. You know the feeling, when everything just clicks into place.
And that's exactly where our story begins. Because the day this genius died, February 23rd, well, it isn't just an ending. Turns out it's the anchor point for a whole hidden network of scientific history.
Okay, so let's dive in. Our story really kicks off on the day that this titan of science, as he was called, passed away.
And believe me, that title was not an exaggeration. Gauss wasn't just a mathematician. He was an absolute force of nature. He made these monumental contributions to number theory, to geometry, astronomy, magnetism, you name it. His work literally laid the groundwork for entire fields of study we rely on today.
And this genius of his, it showed up early. There's this famous story, right? As a little kid in school, his teacher gives the class this really tedious task just to keep him busy. Add up all the numbers from 1 to 100. But Gauss, instead of just slogging through it, he sees this beautiful, deeper pattern. He pairs the numbers up, 1 plus 100, 2 plus 99, realizes he has 50 pairs that all add up to 101, and bam, he gets the answer, 50-50, just like that. It wasn't just clever math. It was a sign of a mind that saw the world in a totally different way.
And that unique mind of his was not confined to just one area. He predicted the orbit of an asteroid using brand new math. He conducted this massive survey of an entire state. He made fundamental discoveries in magnetism. His brain was just a universe of ideas.
But as incredible as he was, the death of Gauss on February 23rd is really only the first piece of this puzzle we're putting together.
And this is where it gets really, really interesting. Because what if this one single date acts like a gravitational point, pulling together the orbits of other incredible minds?
And look at this. This is the hidden constellation. 11 years before Gauss died, another important mathematician passed away on the exact same date. And then, in the next century, you have another one born and another who died, all on February 23rd. It's this completely unlikely alignment in mathematical history.
So let's zoom in on two of these other figures, because they show us that a mathematical legacy can be built in very, very different ways. The contrast here is just so striking. On one hand, you've got Duncan Gregory. His life was this brief, intense flash of insight. And on the other, you have Elizabeth Stephansen, whose legacy was built over a long, steady life of just groundbreaking perseverance.
Gregory died when he was only 30 years old. But his work helped define modern algebra. His ideas influenced thinkers who came after him, setting the stage for the kind of logic that, believe it or not, powers our computers today. His legacy is proof that the impact of a great idea can far, far outlive a short life.
Stephansen, on the other hand, was an absolute trailblazer. She was the first woman from Norway to get a doctorate in science, just smashing barriers for the generations that came after her. But her story doesn't stop there. During World War II, she used her fluency in German to help prisoners in a camp near her home. It's just this incredible blend of intellectual courage and deep, profound humanity.
All right, now let's trace this thread to one more person, a mathematician whose own story begins on February 23rd and connects directly to one of the most famous problems in all of history.
His name was Goro Shimura, and he was born on this day in 1930. He worked in this highly abstract, very niche area of number theory, developing ideas that, at the time, seemed to exist in their own separate universe. But that little universe was about to have a major collision with history.
Okay, so here's the connection. Shimura, along with a colleague, proposed this really radical idea, a conjecture that built a bridge between two very distant islands in the mathematical world. For years, it was a fascinating idea. But then, mathematicians realized something absolutely astonishing. If you could prove their conjecture was true, you would also, as a consequence, prove Fermat's last theorem.
For 358 years, for 3.5 centuries, Fermat's last theorem had stumped the greatest minds in mathematics. It was the Mount Everest of number theory. And the key to the summit, that final, crucial piece of the puzzle, was the work of a man born on this one unlikely day, February 23rd.
So, you see? February 23rd isn't just some random date on the wall. It's a day of endings and beginnings, of brief flashes of genius and long pioneering careers, of brilliant problem solvers. And it really makes you wonder, doesn't it? How many other invisible constellations like this are just waiting to be discovered in our calendar, connecting the past, the present, and the future of human curiosity?